In this video, we will be solving some problems of distance and displacement. So let's get started with this problem. A particle is initially at a position of x is equal to minus 4 meters relative to the origin. It then moves to the right along the x-axis and finally stops at a position of x final is equal to 8 meters. So part A is asking, by drawing an x-axis, show its initial and final position vectors. So we know positions are vectors quantity. So if I draw a line as the x-axis, and if I set in the middle as the origin, set of this axis as 0, the origin of this axis, therefore we have two vectors to show on this horizontal axis. One is x initial and another one is x final, both of which are vectors. So then let's go ahead and draw the first one. So this, let's say this is my initial vector. Somewhere here, let's say, is equal to minus 4 meters. And then the other one, the x final, which is the final position, is somewhere, let's say here is 8 meters away from the origin. So this is x final. So this is part A. Part B is asking, find its displacement. So we know that displacement means x final minus x initial. And x final here is, so let's say displacement is equal to, delta x is equal to 8 meters minus, and we have here the minus 4, so it will be minus 4 meters. So then it will be equal to 12 meters. We can also find the displacement graphically, meaning that we can just draw the vectors and follow the rules of vectors, addition and subtraction rules, and then we can get the displacement vector and we can find out the magnitude of the displacement. And that is, we have two, if you look carefully, we have two vectors. One is vector xi, initial position, and final position, two different vectors. Say delta x is equal to x final, which both of them are, all of them are vectors, minus initial position, vector of initial position. And then I can write in this equation in this form. I can write x final plus minus x initial, because graphically in vectors we always add up vectors, we do not subtract. So therefore we just need to change this equation in this way. Okay, now I am dealing with two vectors. Now I just focus on this equation now. I am dealing with two vectors here, vector final position and initial position. But I need to make a change in initial position. I need to multiply by minus. So I have this vector, which is my initial position, but I need to multiply it by a negative sign and the direction will change. So this is my initial position, and then minus initial position vector will be this vector. Magnitude is the same, but the direction is different. And also I have the previous vector, which is final position vector, and this is my final position vector. Let me write it above. So x final, and the magnitude is 8 meters. So 4 meters, 8 meters. So then now I will follow the head to tail technique in adding up the vectors. I will just place this negative xi, or negative initial position vector, and I will just connect the head to tail of the final position vector. I take this one here, it will be 4 meters, which is my negative initial vector. Now I can see I have two points. One is one tail and another one is one head. So if I draw from the head, the tail to the head, then I will be given with this vector, with this colorful pink vector, which is my displacement vector. And the direction is to the right, and also the magnitude will be 12 meters. So in this case, we also can solve this problem by using the vectors rules, and graphically we can just add them up rather than just write the equation and substitute with the numbers. Now let's move on to the next question, which is about again this distance and displacement. So a toy train moves along a circular railway from point A to B. So this is point A, this is point A, and this is point B. So it draws from this way, okay, all along. As shown in the figure, if the radius of this path is 1.5 meters, calculate the distance that the toy traveled. So if it travels from A to B, when it reaches B, calculate the distance. What is the distance that this toy has traveled? So in order to find the distance, actually we need to find because we see the path is a semicircular way. So we are supposed to find the length of this arc. So this is a length of an arc. Then how to calculate the length of the arc? So suppose we have a, let's say in a general form, if we have a angle alpha, and there is an arc here. We want to calculate the length of this arc. So how to calculate it? And it has the radius r. In order to find the length of the arc, we can say that it is equal to just r times alpha. But this alpha must be in radians. Radians. It means that with a coefficient of pi. So here in our case, this is a half of a circle from A to B. It's a half of a circle, and the half of a circle, if I want to calculate the alpha is actually, the alpha is pi. alpha is pi, is 180 degrees, which in radian we just say is alpha. And now if I just want to find the length of this arc, I say length of this arc is equal to distance, and it is equal to pi r, which will be equal to r is 1.5 meters. So 1.5, if I multiply 1.5 by 3.14, I will get something around 4.71 meters. So this is my distance. So part A is the distance that this toy has traveled. Part A is done. Now let's move on to part B. Calculate the magnitude of the displacement. Of course, the displacement, the direction also is from the initial to the final, so because it moves from this way, yes. So this vector is displacement. This is the displacement that this toy has made. And in order to calculate the magnitude of displacement, we can just simply say it's the diameter of this circle. The diameter of this circle. So therefore, part B, the displacement will be equal to 2 times 1.5 meters, which will be equal to 3 meters. So that is the displacement that this toy has made. Okay, now let's move on to the other problem, which is again about distance and displacement. An object moves from A to B to C to D along the circle shown in the figure below. So the object moves from A, and then it goes to B, and then it goes to C, and then from C to D. So that means that this object moves from here to there. So in order to find the distance, if it is a complete circle, so if it is a complete circle, we say the circumference will be equal to 2 pi r. But it's not a complete circle. Therefore, I need to divide it into 4 parts, and I will see one of these 4 parts is missing, is not included in the path that the object traveled. Therefore, I can say this is one included, 2 portion included, and the third portion also is included. Therefore, 2 pi r times 3 over 4, which will give me the circumference of this, or the distance of this object which has traveled. But now we need to calculate also r. What is the r from this point to here? So, well, it's given 1 meter each unit. So 1 meter, 1 meter, 1 meter, and this will be equal to 3 meters. So the radius is 3 meters, we can say. So they just substitute 2 pi times 3 times 4, over 3 over 4 times 3 over 4. And if we calculate it, it will be equal to 18 times divided by 4. It will give us 14 times 13 meters. So this is the distance of the from A to D. But the next part A, is asking about the magnitude of the displacement of the object makes, and the displacement I need to have a look to see where my initial position is, which is here A, and where my final position is, and that is in this point. So then I can just draw the line straight, actually vector, which shows the displacement. So that is my displacement vector, and I need to find out the magnitude of this displacement. So in order to find out the magnitude of the displacement, I will look carefully, zoom into my figure, and I say I am dealing with a right triangle here, because here I know the side is 3 meters, and here also I know the size of the side is 3 meters. Therefore, in order to find the magnitude of this side, which is the magnitude of my displacement vector, I only need to follow the Pythagorean theorem, which is equal to, actually, in fact, this side to the power of 2 plus this side to the power of 2. 3 to the power of 2 plus 3 to the power of 2, which is equal to actually 18, because 9 plus 9 will be equal to 18, and the square root of 18 will be equal to 4.24 almost meters. So this is the magnitude of my displacement.